Just to kind of recap what you signed up for, our learning objectives today, and I'm kind of cheating on the monitor over here. We've got to explain the relationship between Revit's physical and analytical space, because Revit, whether you know it or not, is already taking its best guess at an analytical model whenever you're modeling geometry. Revit users, I kind of figured that. And then we will use very briefly the structural analysis for Revit tool that you already have access to no matter what form of Revit you have that allows you to access a piece of robot on the cloud. We'll go to robot and back again, hopefully all of us. And then and while we're there, we'll do a little bit of just basic analysis inside and design inside of robot. Okay, so as an agenda, I want to start by telling you a little bit about the Autodesk universe, what we do, what we offer. We're going to get into Revit and just look at it for a second. We'll get into structural analysis for Revit, as I mentioned, and then we'll do the robot round trip. Okay? Letting him take a picture of the screen. I like to build out this slide here and talk a little bit about what Autodesk offers in the, I want to say, the building and plant structural space. We do a lot more than this, actually, but you know, a lot of times we start these projects today in a tool like Advanced Steel. Maybe if we're in the industrial space and they have not been Revitized yet, we'll start a project in Advanced Steel. We'll start a project in Revit. Most of you in here would start a project in Revit based on what you just indicated. You might even start the project in something else like Dynamo or in an external tool like Rhino and push that into Revit to inform design. There are other places you might work if you were doing structural work that's outside of the traditional building space and industrial space. Hey, everybody, you hear me okay? Yeah, in the back, just checking. Everybody awake? You know what, I should give you the option real fast. This is a little washed out. Apparently it's been a thing in this room. You guys okay with that like it is, or do you want us to dim the lights? You want to dim the lights? Okay, I'm going to risk some sleep, but we'll do it. Thank you, sir. I'm afraid we're going to turn this thing up to 11 and blow a bulb or something, so hopefully that'll help. Anyway, you might be using other exotic tools like Fusion that you've heard of plenty, I'm sure, if you've been around this show before. Oh man, this is going to be fun. Going to get the black lights going in a minute. Or maybe there's tools like Nastran InCAD or Sim Mechanical or other, even Inventor, which can tie into robot, but it can also do some other types of analysis. Those are not in the building space traditionally. We do get into some specialty engineering firms that get into all of that, but we're talking about the basics here. So Revit, maybe Advanced Steel, maybe you're even playing with Dynamo. At some point you're going to do some structural analysis. Revit's unique in its ability to communicate with a lot of different tools. It communicates really well with robot, as it should. We own it. And then down the way, we get into coordination. That might be BIM 360 team, early on even. I should probably pull that back earlier in the process to do collaborative work. But it could be any of the BIM 360 tools on down the line. And off the slide would be things like BIM 360 ops, handing off into an owner at handover and allowing them to do operations and maintenance. And then we have some things in the middle that have to do with supplementing this work for fabrication. So there's been a lot of work, and I'm going to kind of highlight that in a minute, in tools like Revit directly to help us get further down the road. But we also have some add-ons that maybe come from partners to allow us to do some automated detailing, for example, in the concrete space. So what does the workflow typically look like? I mean, I'm going to be starting in one of these core products most of the time. I can do analysis. Pretty much everything transfers from Revit at this point pretty well, and Revit does it via a live link. Advanced Steel does it more in an export-import format, but it's still high fidelity. And so you can communicate back and forth. If you wanted to, you could. If you are a glutton for punishment, you could build everything in Robot and push it to Revit instead. And then once you're ready, you can push it on down the line. This used to be all Advanced Steel's purview, right? The detailing piece of this. Over the last couple of years, we'll highlight a little bit of this. Revit's picked up a whole bunch of that capability, and then we get out the door. Really, the shop drawings are still the purview of Advanced Steel, right? So this is kind of your steel workflow. Now contrast that for a second with concrete, and I'll build this out fast. So with concrete, we do the stuff in Revit. We don't do it in Advanced Steel. Obviously, that's not Advanced Steel's thing. We can push this back into Revit. We could have generated all the rebar in Robot, by the way, and it would have pushed back to Revit. And then we can go on down the line in Revit. Now, there are tools like Sophistic Reinforcement Detailing or Greatech BIM Designer or If you're into precast, there's a company called PTAC. I don't know if anybody from PTAC's here, but they make a product called Edge for here in North America, and then there's the new precast concrete extension for Revit to help folks in Europe get further down the line. So there's a lot going on in terms of investment in Revit and its components over time. In fact, I'll show that in a minute, but there are some nice benefits of what we can do, and these are just examples from customers of what they're actually doing, not anything. Actually, somebody said in his post, just said this is one of our connections, or something, and he very much downplayed the complexity of the rebar. You got some steel going on. The Beck Group did this project years ago and let me play with it in Robot. So you have the physical geometry of the structural model, the analytical representation of that model, and of course what it looks like in Robot. I live in Fort Worth, Texas. This bridge is the first precast concrete network arch bridge in the world, and it's just down the street. And they prefabbed this off-site. These are 180-ton arches that they put on a truck with a whole lot of axles and rolled out onto the old bridge and deployed with the crane. And you can see they modeled the heck out of it in Revit. It's a really nice, clean model that they used for precasting it in a field about a quarter mile from the job site. This is a much larger project. This one also happens to be concrete, and we're going to talk about steel example today, so I'm trying to be fair and give concrete a little love. This is ICA, a huge construction company out of Mexico. Maybe somebody here from ICA. But they're going through building a 20-plus kilometer elevated freeway through the middle of Mexico City, which is not trivial. And so they're scanning everything every day. They're feeding the information into robotic bending machines so that all the machines do all of the bending automatically and automatically tag all the rebar. And then they use BIM 360 to coordinate it, and they go out and pick and sequence every crane pick so that what's precast versus cast in place on site can be handled that night before they open the highway underneath the new elevated highway each morning for traffic. So crazy amount of work being done, heavy example of coordination for construction. So for a second, we're going to talk about Revit. I know we're still going through slides, but I want to make a point about where we're going here. This was 2017, and there were 3 releases of 2017 for those of you who still are running 2017 or haven't installed it yet. We did a lot in 2017 around structures, and this is a theme that I could go back several more years with. What you see in there is a whole bunch of rebar stuff and a whole bunch of connection stuff. In previous years to that, you would have seen a lot of analysis stuff. So we were kind of fixing pieces one at a time. If I go to 2018 and the releases so far, because there might be one coming, then you see all of this information, right? So we've got a lot more steel connections, a whole lot more in 2018. Rebar is getting crazy. We want to be able to address rebar in infrastructure projects better, so the ability to do freeform rebar that respects cover settings has been greatly enhanced, and then there's some precast stuff coming along as we go through the year. So pointing out here that there's just a big trend and investment of taking Revit further, and that includes the structural realm. If I look at steel specifically, we can do better connections now, right? This was something extremely tedious to model a few years ago, so nobody did, because you had 2D typical details that you used, and maybe you still do, but you shouldn't, because now you can generate 3D details pretty quickly and fill out all your views, and they're actually correct. So that's one of the big enhancements that's happened in Revit. One of the things a lot of engineers, at least when I was doing technical sales, a lot of engineers would tell me is that they were using Revit for structure because, at least my opinion from being in practice with it is that why would you not use it for modeling structure? It's so much better than drawing something in CAD, for example. If I'm using that for structure, that's fine, but I'm only using it for documentation. I'm not really taking advantage. And folks are either not aware of or have never investigated or tested the analytical model inside of Revit. So it's there, whether you're doing anything or not, and that's what we're going to begin to explore here in a minute. And there's actually quite a bit to it. I'm going to talk more about what transfers between Revit and Robot in a bit, so let's just talk about Revit specifically right now. And for that, I'm going to do a quick exercise with you guys. It's a 2-step exercise, and remember, you don't have to try to keep up. I'm going to give you time to do that. So let me tab over to Revit. And if you want to, if you don't already have it open, you could open up the exercise guide on your phone or something to have it on the side to have the step-by-step instructions, but I'm going to put a simplified version of the step-by-step instructions for you on the screen in a minute, so I'm trying to make it easy. So I'm opening up a model. I'm going to just take a look at it both analytically and physically. So I'm going to just get to a default view here. I'm going to tile that and look at my analytical view. Okay, so in this model, these are two representations of a simple building. I've literally called it simple building. If I pick on a column in this particular building and I look at what's happening in the properties palette, I see the information about its geometry. What level does it start at? Where does it end? Information about rebar cover, because that's kind of physical properties. One thing I like to point out is that by default, this always says enable analytical. You could turn that off if it's not really a structural element. But if I select on the materials in Revit actually carry more information than you might realize, such as the mechanical value here and the concrete properties, which are transferred to analytical tools. So if you use correct materials, you're actually pre-filling out the information you would need to do a proper analysis. So the materials matter in Revit, not just for appearances. Okay. Now if I click on the same column over in the analytical view, I don't see anything other than its length, which matters for analytical purposes. I don't see anything about where it starts and ends. That's not relevant here. What's relevant here is how is this element used? In this case, it knows that its physical material is, it knows its length, and if I scroll down, what it's going to show me is the connectivity, its fixity, right? So this has got fixed top and bottom. You'll note that Revit only has 6 degrees of freedom on or off, so it's either fixed or pinned in these directions. Robot and other dedicated analysis tools are going to be able to take you much, much further, right, in terms of complexity of supports and releases and so on. And some people are probably trying to get ahead already, and I'm just looking back there at you guys. So your first exercise is to simply look at that model if you're not already getting ahead of me, and just take a look at those properties so you understand what Revit's doing for an element like that. Simple building 01. Oh, where do you open it from? On your desktop, there should be a datasets folder. Apologies for that. So and it's not to embarrass anybody, but think about this. If you've never really paid attention, you might have just been going into your view templates or visibility and graphics and turning off this display of analytical stuff in the past, but really, Revit's been building an analytical model for you all the time, all along. Okay. There's a second step to this. I'm going to do this first. So let's go in here. So watch what I'm doing real quick. I'm in Revit, same exercise. I'm not going to go anywhere. I'm just going to go to the Analyze tab, and under my Analytical Model Tools, you'll notice that I can do things like set boundary conditions and loads and load cases, load combinations. We're going to talk about that stuff later. But there's an Analytical Model Tools panel. And on that panel, I can adjust, reset. I've got a supports button and consistency. These are things that allow me to kind of check how my analytical model's doing. And in fact, I can go into the analytical model settings. And if I wanted to, I could have Revit always be checking. I don't enable that by default. It's not enabled by default so that it doesn't bog your model down. But Revit could be automatically checking all the time to make sure everything's supported and to make sure that your analytical model isn't too far out of line with your physical model. So when Revit takes that guess at the analytical model, it might sometimes be wrong. It will. And so if Revit is off, like on some cantilevered beam or funky condition, you can do some correcting of that. But you can also set limits to say, hey, when the analytical to physical model are too far out of whack with each other, and therefore I'm probably not going to get a good result when I go over to my analytical tool, then let me know. And so that's some of the just basic settings that can be done in Revit. You're going to be doing that now. Let me cancel out of that. And so for example, you can, when you get to it, step 7 there will let you just run one of those checks. So just to show you guys that last step, right? If I click on this button, it says check supports. I'm going to get this message at the bottom. It says the support check is complete and nothing has been unsupported. So it's actually a warning saying you did a good job. Funny enough, with data sets in a lab, everything works. So yeah. What's that? It's you add them. Yeah, you can add them in.
Are you adding them in Revit or are you adding them in
Yes, we'll talk about that. It's been many years. But you got it? Good? So there were a couple questions. One of them was about adding loads. We're going to get around to this model's got some loads on it. We'll talk about that here in a few minutes. And then yeah, it's been a few releases that this has existed, maybe 5 or 6 releases as a feature. All right, there's a little tool that nobody seems to be aware of called Structural Analysis for Revit. It's existed for a lot of years. As anybody that was on subscription back in the time, and of course pretty much everybody now, would have access to this feature. This is not a full-blown structural analysis software. It is a piece of robot running in the cloud that is tied to Revit. And so with Structural Analysis for Revit, I'm inside Revit, I'm working, and as I'm still developing my model, maybe I'm not ready to send it over to robot or an equivalent finite element analysis software. I want to just understand its static and or gravity performance, just to make sure I'm building something that's going to stand up before I get into anything more detailed. And I can use this tool to do that directly from Revit, view the results either in my browser or back in Revit. And so with this tool, there's a simple dialog. I'll show you what it looks like in a minute, and then you get to do it if you have access. If you don't, I've already pre-baked it into the dataset file so you can look at the results. And then when you get into your browser, so what we're going to see in Chrome is that we can look at how this building performed under the cases that we examined. And so with that, I think it's time to do that. Yeah, so these are really warm-up exercises, by the way. We're going to get in the good stuff later. I think it's a 35-step exercise when we get to Revit and Robot. Okay, so I have my analytical view open, and I have to have an analytical view open, so just watch this. You get to do it in a minute. And if I go to my Analyze tab, and I've got my Structural Analysis Toolkit installed, which you do, then I'm able to analyze in cloud. And this is basically just sending it to this service. And, okay, good, this worked out with screen resolution. Don't worry about I've got a lot of shared parameters stuff. So it's going to check my entitlements, blah, blah, blah. And then it will pop up with a dialog that gives me options to configure this thing. What's that? Yeah, so if you don't have it, or maybe it's because these are frame, virtualized instances, don't worry about it. That's why I populated the dataset file. But what I can do is configure multiple analyses. So I have analysis 1 here. Is it going to be static or gravity? If it is gravity, by the way, then I could go ahead and reduce live loads according to code. And so it's a basic configuration for a static or a gravity analysis, of course. And then I could add more. So that was a gravity. Then I could configure a static analysis in the same way. I can give it a name. I can tell it to go ahead and put the self-weight into the dead load 1 case, and et cetera. So it's just basic. It will tell you, as you can see if you look close at the bottom of my screen, how many cloud credits this takes. It's a very low number. So a couple of cloud credits per run. So if you ran out of cloud credits, if you haven't bought those before for your firm, they're basically $1 a credit. So you could go to another application and spend all the time to get that model worked out and see if that saves you $2, or you could just click the button and instantly get the result back. Your call. But anyway, once we've run that, and I'm gonna stop there. Once I've run that, then I can look at the results. And I'm gonna see if I broke this up for you guys. I may have done it in 2 pieces just to let you do it. So if you haven't already, go ahead and just open up the O2 dataset file. And I guess because you're all running it in frame, you're not going to be able to do steps 2 and 3. So I'm going to jump in a second here to viewing the results that happen once you have gotten the results. But I'm going to show you what it looks like in Chrome in the meantime. You'll need that file open, though, for the next part. So I've got this file, and let's say I've just baked the analysis, and of course I've cheated and did it in advance. So if I go into my static result, for example, for this structure, I can then begin to look at those results in the browser. Now, I have a lot of options here. I won't get into this too much. I can look at a deformed shape on it. I can zoom in and spin this thing around like as if I'm doing something inside of the Revit environment itself. For my case, I want to, let's see what I'm thinking about what I'm going to do. I don't want to just do reactions. I'm going to do, you got to bear with me. I'm working out the fact that I don't have any screen resolution here. So maybe displacements. in the Z direction. And let me turn off detailed results for a second just to fit it. So this is probably all I need to show you. So I can look at this model, I can spin it around just like I would if I was in the Revit environment. It's showing me the deflections. If I wanted to, I can open up just a map of the surface, or maybe I'm just interested in a certain level of displacement, something that's over, let's say, 1.5 inches. And this is telling me where my building is struggling, right? Very quick visual feedback, easy to do. I can also view this in Revit, which is what we're going to do in a minute. So if I go back to Revit, the next thing that all of us are going to do is, I'll do it first, is I'm going to go to the Results Manager, which is still on my Analyze tab. And one of the options I have, what this does is it looks to the cloud. And if I have analyses of any kind in the cloud, it's going to show them. But I'm also able to download them. So you see I've got these two selected. There's a grayed out download button because I've already downloaded those into the project. They say in project. So I can save them with the project like I did for you guys so that you would have access to them regardless of the internet. But I can also remove them from the project so I'm not collecting old analyses results and bloating the Revit file. And then once I find them, so I'm going to find, in my case, the static analysis, I'm going to explore that. What it's going to actually do is open that up in the Revit environment. I'll close out my other toolbar. And what I want to do is look at the displacements in the Z direction in the same way I just did in Chrome. And what you'll notice is the exact same kind of graphics are showing up now in the Revit environment. It's the same robot engine driving it all. So I'm just looking at UZ displacement inside Revit based on the static analysis case that I ran through structural analysis for Revit. And now that I've done all that and said all that, let me close out Chrome and switch you guys back to where you can see the steps for that. So this is from the O2 SAR file. We all good? Okay, got the easy ones out of the way. So just keep this in mind as a tool. In fact, I'll address this now. There's been a couple questions about, yeah, but the loads need to be in Revit, right? If I didn't have access to Robot, either because I'm not the engineer, I'm the guy doing the modeling, or because we just don't have it, then I might apply loads in Revit, especially if it's a simple structure. I wouldn't do load combinations, for example, if I had access to Robot because it does it automatically over there. So why would I do that manually in Revit? But if I'm someone who knows what I'm designing, what I'm sizing my members as a first guess based on, then it's very easy to apply point, line, and area loads inside of a Revit. So the basic load cases, yes?
Can we do the same as we did in the web browser to edit or filter out the results?
Inside of Revit? No, I don't think so. Yeah, it's a question there had to do with, can I shrink the envelope? And that's a unique feature in Chrome, I think.
We do have boundaries that are just grayed out.
Yeah, well, that's a good question. Yeah. So anyway, so I might apply the loads in Revit, but there's kind of a limit on how much I would do. In the same way as I would, potentially I could define that this is a fixed connection inside of Revit, but if I'm going to have some complex damping at a connection or nonlinearity or something like that, Revit can't represent that. So there are going to be things that I need to do in my FEA tool. So, okay, let's move on. Got to get to the good part. So Robot, what is this thing? You'll hear it described, by the way, in multiple ways. So RSA, Robot Structural Analysis, is a common way that you'll hear or see Robot referred to because its name is really long. So anyway, Robot or RSA. This is what we call a general purpose finite element analysis platform. In that way, it's similar to SAP 2000 or STAD Pro for people that are used to those tools. A little bit more general purpose and in some ways heavy duty compared to some of the other tools that are out in the space. I mean, you'll see RISA, RAM, ETABS, other tools out there, but there are some tools that are just designed to do anything from a finite element analysis perspective, and Robot's pretty wide open that way. It does have over 70 codes that come with that out. There's no extra modules to buy, it's all in the package. And part of its strength is the fact that it grew up in Europe, started in 1985, so it's only a little bit newer than AutoCAD, and is a very mature engine. It has extremely strong Eurocode support, including connections, which unfortunately we don't have full-on connections analysis here in the US, I guess, because nobody else does and we don't have a business case for it. But it has extremely strong support over in Europe, and then it also has a lot of support around steel and concrete in the Americas, as well as NDS for timber. So it covers a lot. It covers a lot of industries as well because of the fact that it's not a building-specific software. It does have a sort of a building workspace, but it has many others as well. So it's used all over the place. And I'll show you some customer examples that confirm that. I think one of them, well, I'll talk about it in a minute. That one's pretty cool. I mentioned this, reinforced concrete, steel, timber. It doesn't do precast, or I'm sorry, not precast, post-tension concrete. That's usually done, and there's a couple of specialty tools that do that. We can talk about that if that's an interest. But it does just about everything else. If I get into types, I know, so you see analysis types right here, right? So any of these types of structures. I will say, like, the composite beams module is similar to the composite beams extension for Revit. It's an extension instead of just out of the box. And then it gets it gets into the weeds. I mean, in a way, like, so some programs do finite element analysis at their core, but you don't even really see that. So they're numerical solvers at their core, but that's kind of hidden. They're more simplified for the end user, which is great for a novice engineer and frustrating for somebody who really wants to control everything. Robot's exactly the opposite. So, you know, what's the size, shape, and positioning of your finite elements? What is the numerical solver that you prefer to use? Like, it goes as far as you really want to go, which is good and bad. Could be intimidating. It does cover nonlinearity in good detail. So I'm thinking of, like, I'm just really honest with you guys here. So, like, the only example I've ever seen was, like, it covers nonlinearity and damping and buckling, deformation, deformation during buckling and its effects on analysis. All of that's included. I did run into one engineer who wanted to change not only his stiffness matrix, but his damping matrix during the process of deformation and buckling in a nonlinear fashion, and our product guys were like, huh, nobody's asked for that before. We can do that. So it's really, you know, it's a pretty mature product in terms of capabilities. Certainly can handle typical developments and even some of the really crazy developments that you'll see out there. Dynamic analysis is also heavy duty, so all of the standard stuff plus things like footfall analysis, moving loads, and I don't really talk about loads here, but like moving loads, notional loads, thermal loads. It's just a very capable product in general. There's a unique feature called the wind load simulation. This is different than the snow and wind loads per code. This is actually really unique to Robot because it takes a piece of our simulation CFD product and puts it inside a robot. And this would be used if you're in a case where the traditional snow and wind load approximations are terrible because it's a complex building. And so instead of immediately having to go build a physical prototype for a wind tunnel test, you could essentially run a wind tunnel test inside Robot that generates the actual loads on all the surfaces based on your specified pressure, velocity, orientation, and vertical wind distribution. And then at least, even if your code official wouldn't accept this, at least you'd know your physical model would work before you spend all the money to build one. Okay, so this is not related to codes. This is much more accurate than a code-based target approximation. And it's unique to be able to do this inside a robot. It's also, because of its maturity, this is becoming more and more important if you guys are paying attention to Forge and other terms that you might be hearing around Autodesk University, because not only is it got a full-on API that's been developed over the past 30 plus years, but it has a tool called Results Connect. It's actually an add-in for Microsoft Excel. It used to be called Project Octopus for some reason. But this ships with Revit out of the box, and you install this add-in inside of Excel, and then what you have next is the ability to see live data exchange between Robot and Excel. It's really distracting. Thanks. So anyway, you're able to feed in information, and if there's anything that Robot doesn't do that you want it to do and you don't want to code, well, you can write it in Excel because Excel is incredibly powerful at writing equations, right? So something to keep in mind. And then there's Dynamo, of course, and Dynamo and Robot had integration a while back. That little screenshots from ABT, a company overseas that does wind turbine foundations, and as simple as it might look, it's kind of a layered approach where you have to decide this before you decide this, before you decide this, before you decide this, and they took a 2-week process and made it a half-day process by automating that with Dynamo for any given situation. So making some money on doing work that is kind of repetitive but not. using Dynamo inside of Robot. Some customer examples, some you might recognize. Like that little bridge over in France, the wind torsion on the deck was done in Robot years and years ago. This building just opened in Abu Dhabi. And so that was analyzed in Robot, very basic building. Then you have this World Cup stadium from Brazil a couple years back when they did the World Cup series there. There were a couple of them. That was Bro Happold that did that in Robot. So this shows that some of the non-standard capabilities of the product. Obviously, you see a lot of freeform shape stuff going on. I've got the model we're looking at today is going to be the simplest thing ever to do an analysis of, but I've got a cable-stayed bridge with 127,000 load combinations that takes a little longer to run. And so it can handle any of those scales. One slide before we get into the exercise, just to kind of remind you or get you back on point for what we're going to do, is that there is a lot of stuff in Revit and in Robot that transfer back and forth. And I just came across this the other day that one of our internal guys put together, but it helps to kind of give you an idea. You don't have to memorize that. There's not going to be a test. But a lot of stuff transfers back and forth. And that's not always the case with third-party tools. I have nothing against using third-party structural analysis tools, but I would recommend if you're a Revit user that you look at what you can and can't transfer well. Because some of them are more of a one-way trip, as many may have learned the hard way. Some are pretty good at transferring pretty much everything back and forth. Maybe you have to use a third party to do that. We make it a little bit easier. Again, we kind of have to. We own it, so we don't have an excuse. But it's a very solid. It suggests, this connectivity suggests that you should be looking at doing integrated workflow. You should not be, as someone told me. I don't remember if they're sitting here. Someone told me earlier today that they're sitting next to their analysis person, building their model and building their model, and I'm like, that just grates me, right? Like I would not be able to stand that because that's just duplication of work when it's unnecessary. Okay, so with all of that said, it's time for the real part of this class, exercise 3. Now I'm gonna lead off. We're gonna start in Revit, friendly confines of Revit, and then we'll move into Robot, and it's gonna be painless, I promise, and we'll walk you through it a little bit at a time. So I'll do the same kind of thing I've done before, where I'll put it up on screen as I go, and I'm just gonna preview what I'm actually doing. Sure. Okay. So I've got the wrong model. Let me get the one that you guys will be using open. And of course, mine is organized slightly different than yours. All right, so I'm still looking at the analytical model. You always have to be in the analytical view when you're sending information back and forth. So I'm going to start by going to the Analyze tab and going to a section I was not in before on the structural analysis panel that says Robot Structural Analysis link. I have a few options. I don't have a ton of options. I'm doing direct integration because I have both on the same machine, as do you. Hopefully that'll work with Frame, and if it doesn't, we'll use the intermediate file because this always works, right? So I have options when I send, by the way, to send only stuff that I've selected. So the question that commonly comes up is, do I have to send the whole model every time and rebuild it? No. I can just grab that batch of elements and send them back over. Okay, so I can update things without taking forever. I can choose a case that contains weight, and then I have ability to send over plan views to use them as backgrounds. I find it distracting, but it's cool. You can send over reinforcement if you got it. You can send over connections if you got them. I don't care about any of that, so I'm just going to hit OK. Now all this will do is say that it's exporting. I don't even have Robot open. If I have it on the machine, it should open it up next to it. Again, I don't know if Frame will behave, so we'll address that if we need to. But what's happening down here, I promise, because you can't see it, is that's Robot opening, and it's building the robot model. It may take a second just because it's projecting and whatever, but it's not a big model, so it won't take long. Now, in my case, and this is probably a good place to address this, we're going to see that loads are on that analytical model and it transferred. Again, you could put those on in Revit, you could put them on in Robot. You don't have to have anything besides the geometry. And in fact, if I were using Advanced Steel to do the transfer instead of Revit, it would just be the geometry that's transferring. It's unique in Revit that there's this attempt at making an analytical model and that it will share that information to outside tools. I don't need to see the events report. I could say yes. I'm not going to worry about it. But I have a model in Robot. right? And it looks a little different, but we're going to talk about that more in a minute. In the meantime, I think we're going to go there and let you do those first couple steps, just so we keep in pace. Staying robot models. Yeah. Easy cheesy. No. You're a different part of this thing altogether. Yeah. The view, so close that. Go to the view tab at the top. Top left. That's where we're going. Yeah. No, it's display. You're getting ahead, but that's fine. Yeah.
Does the load analysis have to be done first if we were to do this in our log? That what case analysis that requires or is that all in that?
Yeah. Yeah, we're going to walk through it. Yeah. No, that's good. That's good. All right. Keep hollering at our lab techs if you have questions. Okay, so for the next set of steps, now one of the things that I saw somebody already trying to work on, is that sometimes you don't see the load stuff appear. Like I see that it didn't come over, and I know that I have it in Revit, so I'm going to just do a real quick check. I'm going to go to the View tab, Display Settings. I'm going to make sure that my load symbology is turned on, and now I see them. So in this particular example, I already had the loads in Revit. I don't need to duplicate that effort inside a robot. You'll get a chance to do that in a minute, so don't worry about it. Let me just see what else I wanted to do right next. Okay, so the other thing I want to show you, so take a look, is there's similarities and there's differences between Revit and Robot. You might want to kind of watch this. So the top left here is what's called an object inspector. Think of that as your properties, as your, help me out, project browser, right? Show me everything that's inside the model. And then if I pick anything inside a robot, I see the properties of it. This properties inspector is like the properties palette, right? So it's similar in that regard. It's also a little bit different. Obviously, the display looks different. If I want to, I have almost the equivalent of the view control bar at the bottom left of my display window, if you can see it down here. So I'm able to turn on, for example, section shapes and start seeing that, a little bit more detailed. I think this is, to me, it's more distracting, so I leave that off. And I don't necessarily need to see the load stuff, so I can turn on and off display of load values, display of the load symbols, and keep it clean. Okay? So go ahead and take a minute to, if you haven't already done that, to go ahead and turn on the load display if you'd like. And like I said, in step 5, it talks about that. You may have to go up to the View tab towards the top left of your screen to see that. And then you can play with those settings at the bottom left of the window to see it different ways. It's a good group today. You guys are cranking. I like it. It gets... Oh, what am I going to have you do next? Okay. So one thing I noticed when I first built this model, I want to make sure that I'm analyzing the floors a certain way. And so I'm going to have you guys follow me here and make a couple changes to the model that also point out something that Robot does. So if I'm looking at this model right now, and I see that this slab is currently being calculated as 2 ways, or a shell. So I'm going to change that to be a 1-way deck slab. I'm going to do the same thing for the floor above it. I'm just picking on the floor. I'm changing it to a 1-way slab. That's very easy, nothing to it. So go ahead and do that. So you'll have to select the floor by kind of selecting by its edge. And then in the properties inspector, it should be towards the bottom left, change those to one-way slabs.
Select it from this top side toolbar as well.
No, I'm not gonna keep it simple. No. We're not looking at that right now, but if we went to a plan view, we'd be able to yeah. So it's just, it also would be visible in Revit if you had designated it that way in Revit, right? Yeah. Yeah, you have it on the app, yeah. PDF. But. Okay, everybody good? Real quick, easy? With me in the back? Okay. All right, so the next thing I'm going to do is get into loads a little bit and generate some load combinations. So to do that, and watch up here. So what I'm going to do is, this is what we're doing next. We're going to start out. We've got the geometry from Revit. This is all logical, right? Every structural analysis tool is going to be like this. We start with geometry, whether we inherit it from somewhere else or we build it here. Then we work out our loads. We do the analysis. We look at the results, and then we do some design. That's what we're going to be doing over the next number of steps. Just walking across the tools inside of Robot. It's intuitive. So in this case, we know we have geometry, and we checked our connection supports and stuff. We're going to presume in this particular case it works because I know it does. But anyway, we have some loads that were defined in Revit. We need to generate load combinations. I didn't generate those in Revit because they're not automated. I'd have to manually do it. So why would I do that when I can do it fully automatically? So I'm going to go into automatic combinations. I'm going to choose full automatic combinations in accordance with ASCE 710. If I look under the more, I've got ultimate and serviceability information here. I hit generate. I've now generated all my load combinations. Okay? So in your case, a lot faster than typing those in manually, of course. Everybody there already? Easy? Click those three buttons. Questions? Okay. So we have loads. We have load combinations. We have to start setting up how we're going to do our analysis next, okay? And so in that case, what I'm going to do is get into my finite element meshing setup. So follow me along here. I'm going to move now. I could go into the analysis tab and I can get into meshing there, as you see on the screen. But there's actually an options toolbar I'm going to open up here just to have it floating so it's a little easier to see. Oh, that's funky. Look at my screen resolution, it's doing some funny things. Okay, so in this case, I want to go into my meshing options. So watch it up here, you're going to get a chance. And I'm going to say, go ahead and do it for all the panels. I'm going to do a complex mesh generation and just randomly pick 2 feet. If I wanted to, I could get into advanced options, and we don't. So I'm just going to cancel back out of that. But once I've chosen my options, then I can mesh this thing. So I simply click a button there to mesh it. And once it's done being meshed, I can freeze the mesh so that it doesn't recalculate every time I run an analysis. So I do those few steps, and now I have this model with finite elements showing on it at 2-foot intervals. So we'll let you guys go ahead and do the same thing. So for those, I'm going to say this, and everybody in the room might know more about this than me, but I'm just going to say this anyway. If you're not familiar with finite element analysis, it's a numerical method to approach and basically break a structure up into arbitrary small elements so that you can treat it as if it's a linear problem to solve as opposed to a nonlinear problem to solve. And so structural analysis tools typically use a finite element approach to break complex shapes up into something where rules of approximation can apply. That's the simplest way I could possibly say that. So, but you need to have a mesh, bottom line, if you're going to run analysis in an FE tool. Okay, so there's a question about switching units because for some reason the designer wants to use one system, let's say Imperial, and the engineer might use SI. You can set up your job preferences in Robot, and I would set them up to match whatever the designer is doing, and you could set your display units to be something different. So they could display one thing and be actually calculating to make sure that you don't import something at a factor of 3 point whatever, or, you know, some odd result. Okay, so we've got this thing meshed, hopefully. The next piece to this will be to begin going into analysis. Now, if you look at the top of the slide, if you're lost or it's not working, please open model number 4 right now. It's the robot file inside of Robot, and you'll be caught up. Now, this is going to be really easy. We've got this thing meshed, and in my particular case, I don't want to see the mesh anymore because it's complicated. So where would I go? I would go down to this equivalent to the view control bar and just click the button to turn the mesh back off. So it's nice that I have that ability to control everything and keep it simple. But here's what you need to pay attention to. Here's where we go into analysis. We're going to do the easiest analysis ever. I'm going to go into analysis types. And I've got this set up as a linear model right now. It's just a linear analysis problem. I have the ability to go crazy with this, right? I can go into a new type of analysis, and then I have to run one of my basic dynamic analyses before all of the other options become available, but I could go into modal analysis and get into that kind of stuff, or I could get into parameters like P delta and large displacement analysis if I really want to get into that, or I could go into run a parallel direct analysis method approach alongside of an FE approach. So if you guys use the DAM, then you have access to it by just checking the box. Full implementation of direct analysis method is here. But I'm not going to do any of that. I'm just going to hit calculations. And this is a simple model with not that many load cases. So my analysis, as you can see, is going to be done in like a number of seconds, and I'm complete. Now, having done that, if you look at where my cursor is, there's a green light I have at the bottom of the screen telling me that my finite element model is now available. So it's calculated, it's current, nothing's changed. If it had changed, it'd be yellow. It's telling me I have a current finite element model available. So do the same thing on your end. Either with the file you've been working on, or if you're worried about where that is, then open up file 4 and take these 2 steps. I mentioned the program dates from 1985. Okay, so has everybody got this far? Green light? Yeah? Easy cheesy? All right. The next thing is I'm going to look at this stuff, and we're going to get the same kind of graphical feedback because we did the same kind of analysis as we did in our static analysis earlier. We're going to get the same kind of graphical feedback as we got with the structural analysis for Revit tool. So in this case, I want to go to results, and I'm going to look at, in my case, I'm going to look at maps because I'm going to look at panels, and I'm going to look at displacements in my Z direction, hit apply, and lo and behold, this looks a whole lot like it looked inside of Revit running the structural analysis for Revit tool, right? Okay, is everybody seeing results? Or most of us seeing results? Okay. All right. I'm going to turn those back off as you guys did if you followed the instructions on the slide, and then it's time for us to do a little design. Where do we need to design? We need to fix that top floor, right? That roof or top deck. So I'm going to turn off this display. Apply that so that goes away. Now, one of the things we have not been doing is changing our layout, but there is a tab up here at the top. This is very AutoCAD-like for those of you who originated in that part of technology. There's something that's like a workspace called a layout. And in this case, I'm going to switch to steel design, steel aluminum design, and it begins to reconfigure this. It doesn't have quite enough room based on my screen real estate right now, but that's fine. To reconfigure this interface for what I should care about when I'm doing design. Because we've already determined what our problem is. We want to fix members in a particular area on that top deck. So I'm changing the layout to just give me what I need to look at. And one of the things Robot does whenever you do this is gives you a set of icons down the right side that are relevant to what you're doing. So I would be seeing, tools I actually care about. we're going to do a very simple analysis. This is code group-based design for steel. This is where you group a bunch of members together and you make them all the same size, whatever's the most optimal shape for that group, because you don't want to order 30 different beams for 30 different slots. You want to just order one beam that sort of works for all those slots and lower your risk of things not working out on the job site. So in this case, I'm going to go into groups. Watch what I'm doing. You'll get a chance to do it in a sec. I'm going to make a new group. It's just going to call it group 1. Now, in my case, I know what these are because I've done it before. There are about 100 selection methods in Robot. We won't get into that today. You can search in many ways for members, but in this case, I want 104 to 123. When I hover over those members, I'm seeing their numbers. And so I'm going to actually just type this in. It's like a cartoon, 104 to 123. Okay? And then I'm going to save that list, hit OK. And then when I come down to my calculations, maybe I'll stop there for a second, let you guys do that part, just so we're there. Go ahead and create a code group, which requires you to change your layout based on what I just did. So once you have your code group defined, it's going to be time to do the actual design based on that code group. So I'm going down to the calculations panel at the bottom right, and watch what I'll select here, and then I'll put that up on the slide. So in here, I'm going to do a code group design. I'm going to check that box. I can list my groups. I only have one. It's called 1. If I had a bunch of them here, I could select them and send them all up into my list, or I could type it in. Doesn't matter. But I'm making sure I have 1 in this box so that it sees that's the design I care about. I'm going to optimize this group based on its weight. So I'll check optimization, go into options, and I'll check weight. You notice you can add additional restrictions. Maybe you have a maximum section height that you can achieve in that building, so you add that as a characteristic. I could have, but I don't. In this particular example, I've allowed the entire AISC section database. There are more than 50 country-specific section databases inside of Robot. I'm allowing it to pick any member, but it's going to probably pick a wide flange because I already have one if it can find one in that category. You could restrict that member list and say you can only pick from these shapes and these sizes. There are lots and lots of options. We're just hitting the basics. So I'm optimizing based on weight. I hit OK. And when I'm ready, I hit calculations. And what it's going to do very quickly is spit out a set of calculations giving me 3 possible shapes. You see there the 6 by 25, 8 by 24, and 14 by 22. And it tells me why I should or shouldn't use those sections. So in this case, you'll do, let's see, have you done this part? Nope, you'll do this part. We're getting there. Only a few more steps after this. So this is on that palette towards the bottom right. You're going to do some calculations. So why did Robot pick the sections it did? You can certainly look at that, of course. Some of you already are. So if I look at the 14 by 22 here, for example, it's a little bit lighter than the 8 by 24 that it's recommending, but why does it not work? Well, we can select the little icon and get kind of a report on this that's telling me there's a slenderness problem if I read through all the notes. And I can kind of hit calculation note and see this more in a text thing if I need to report this out, right, according to the code that I've got selected. And I see, okay, well, that's not going to work. I can close out of that dialog. Why does the 8 by 24 work? Because it checks all the boxes and it's stable. So when I'm happy with the result, I'll say change all. And it's going to tell me that this is going to make the database change, and therefore my finite element model will no longer be current, which of course needs to be the case. So I'll say, yes, let's go ahead. And it's just changed them all very fast, believe it or not. And when I close this, it's going to say, do you want to save that result? So if you're iterating through a design process, you could save the result each time if you wanted to make sure you knew why you made the decision you did when you did. I don't care in this case, so I'll cancel out. But those members have been resized. And so if I switch back to the show, you can go through those same 2 steps. A little more text here. All right, so the important one is step 32 there. You got to have the new sizes for this to have made any change. Once you've done that, let me see what's going to be next. Yes, of course. So we're going to take this information back. Now, I'm going to switch back in my layout here to structure model, structure geometry. That's where we started, just so you see what it looked like when we first got into RSA. And if I were to pick on any of those beams upstairs, you'll have to trust me because I didn't show you before we started, but they were not originally 8 by 24s. They were 8 by 10s. If you don't trust me, I'll tab over to Revit. Take a look at the size of the members in Revit. You'll see that they're 8x10s because we haven't updated Revit yet, but that's what we're going to do next. So they changed to 8x24s, and now it's time for me to take that information back to Revit. So to do so, I could do that from here. Now watch what I'm going to show you. You don't have to do this because we have Revit on the same machine. I could go to the integration with Revit Structure and export this out to an intermediate file from Robot. So if I didn't have Revit, no problem. But since I have Revit, and keep this in mind, I've never saved that Robot project, right? We generated that from Revit, and we've been working in it this whole time, and Revit's just sitting out there on the side, but they're still connected because they were both left open. So I'll go back to the same place in Revit I went before, Analyze tab, Robot Structural Analysis link, and this time I'm going to update the model. And this is a small model, so I don't have anything selected in Robot. It's going to just grab the whole thing and rebuild it in Revit, but it's fine with that. I'm going to do direct integration, hit OK, and it won't take all that long because it's just doing this process in reverse. If I had the museum in Abu Dhabi, I would not do that. Yeah?
Aaron, does that work if it's on different machines, for example, structural engineers on desktop?
Yeah, so I just pointed out where the intermediate file is, so you could send it to the intermediate file if you needed to do that, right? If they're not on the same machine. That's right. And in fact, we have the intermediate file. You saw that didn't take too long. It's completed successfully. If I had wanted to, and I clicked yes, but I don't need to. If I had wanted to, I could have, because I saved it in your datasets folder, there's an SMXX file. You could have opened up that SMXX file to get started in Robot instead of doing the send from Revit in the first case, or vice versa. We could push it out that way. But in this case, we've acquired that information back from Robot live because they are on the same machine, so you'll go through those same steps. Oh, you're not there yet. And per Will's question, you see step 34, you could have used the SMXX file to update if you didn't have them on the same machine.
And that is what we need to do if we're in advanced steel as well.
Yeah, in advanced steel, it's only a geometry transfer, and it's never a live link like this. That's right. So has everybody been able to do this? And if you want to verify how this is done, or that the result worked, this is what I did not show yet, but if I go back over to Revit, I don't need Robot anymore, and let me go to a geometry view. There's this beam system at the top. I'm going to hide this slab for clarity. This is actually part of a beam system, but you see it's an 8x24 now. So one of the questions somebody asked in the audience earlier was, what if I have beam systems, they don't come over into Robot? It doesn't matter because the Revit Robot interoperability has been designed so that it will override the individual elements as if you had gone in and manually done that inside of Revit without breaking the beam system. So if I were to make further changes to the beam system in Revit, then I would have to be aware of the fact that I'm now messing with, by redefining it, the beam system in Revit, I would now be messing with the member sizes and stuff again, right? But it's not breaking anything. It's respecting Revit's rules while allowing you to override based on what you learned in Robot. So it's a pretty sophisticated relationship between the two. And I just verified that's an 8x24, right? So it's now done that, even though the beam system definition, if I were to select the beam system itself, might tell it it's supposed to be an 8x10 by default. Yeah. I'm sorry, you'll have to correct that. Yeah, so this that relates to what you guys were asking too. So there was a question about mapping of members. Autodesk did a lot of work. This is like 4 years and 3 years ago, or 5 years and 4 years ago. First to bring Revit and Robot sort of to parity in terms of their section mapping, and then to start building in the enormous database of sections that Advanced Steel brought to the table. So now those three products, for the most part, they're mapped really well. There still will be exceptions, and if there are exceptions, it'll bring up a mapping dialog and ask you to pick the equivalent section. So it's no big deal. If you have custom families defined, obviously, then you'll have to address that. The system definition for that beam system still thinks your definition is 8x10, which is correct, because that's what you told that the beam system rules are. But it's like as if you went in and manually overrid all the sections in there to be 8x24, so it's doing the best. It didn't break your beam system, but it also didn't break your robot results. But you do need to be aware of what you did, because now if you mess with the geometry of your beam system, your members are going to want to revert to being the right size as defined by your beam system. That's the risk there is if your modeler is lazy. Yes, that's right. there's a risk. There is a risk. Yeah, that's true. But that's right. It's to be aware of. But it's the kind of things that when we were first testing this, we would test stuff like that to see if it would break, and it works. It's just there's some complexity there. So if you guys managed to get through this, who got through this whole thing? It's like 90% of the room. That's good. Good. Nobody jumped ship. We can come back and fix that. That's awesome, because this is it's a logical sequence, but it's a lot of steps. So we gave you a very easy example. A very hard example is not actually a whole lot more work. You just have a lot more complexity in terms of setting up the rules of analysis, but it's the same sequence. And they work together, and you can do this multiple times. Again, if you wanted to, I mean, I know guys that they're just structural engineers from an analysis point of view. They love the robot environment for some reason, and so they model everything there. You can do that. I worked on a project with the U.S. Air Force Academy Cadet Chapel, which is a very complex building, and we had somebody hired as a graduate intern that built the entire thing from the original plans as a robot model. It's actually a React model, the same difference. And he pushed the button, or I pushed the button because I'm a glutton for punishment, pushed the button and generated a Revit model from something that was never intended to be a Revit model. Now, it took 40 minutes, and it's got some 500 warnings, but it worked. And I would have to then go through and clean up that model. But the fact that I could do that I could take an extremely sophisticated structural analysis model that had never a thought towards working as a geometric model, and I could do that and get 95% of the way there in a click was really cool. I'm going to remind you guys now, I know it's like 8 minutes to go, the surveys, because I'll forget, and then I'd love to do Q&A with you guys. Yes, sir.
Which Autodesk packages include robot?
Collections, AEC collection, and I'm not sure if the manufacturing ones do. Does anybody know? Product design and manufacturing collection might also include robot.
Not the old building design suite.
Building design suites are, well, the old building design suite Ultimate did, so if you still have that on subscription, you would still have access to robot through that, yeah. Yes. Go ahead. Work. Yeah. Yeah. Yeah, so there's a question about training videos. There's some awesome training videos that are not in English on YouTube, because we have a lot of expertise in Europe. So the best resources I found, there is a Mastering Robot Structural Analysis professional book you can buy off Amazon that a buddy wrote that's like a multi-100-page guide, so that's a pretty good learning source, but that's a book. I have, if you were to ping me directly, I have some really, really old RSA feature-by-feature videos from back when we acquired it that are on a hidden website that I can share, because they're really old, UI and everything, but the feature steps are the same, so it would still work from a learning perspective. And then you have a lot of AU classes actually over the last number of years. I don't know how deep they get, but it's worth looking at AU online. Thanks. Yes, David. Yeah, not only, and then you have companies like independent consultants like Eichard Consulting that'll.
Thank you, but I also was going to say the certificate of development and curriculum
Yep.
is adding robot 18 subjects coming out in January.
Okay, cool.
But they've done a medical office building. Now that is moderate size and moderate land, but it takes it all the way through design
Okay.
with robot mode, just in robot and then Revit maybe.
Okay, good.
Into advanced skills.
Good.
It's cd-bim.com. It's a holistic curriculum for BIM workflows.
We should talk more about that. Will.
They're featuring, they feature other applications
Sure. Great. So you guys got that? cd-bim.com. Other question? You had a question. Reinforced concrete's fine. I was just saying the only thing you can't do is like pre-stressed or post-tension. It can do like a reduction in loads for pre-stressing forces, but it doesn't do post-tension concrete design, right? Like it's, yes, it does very well. In fact, and then the other piece of that that I think is important, and I kind of mentioned it in passing earlier, is he's asking about concrete workflows with robot and with foundations. But the rebar itself, the fact that the rebar can be generated, both theoretical or provided reinforcement can be analyzed, but it can be generated in Revit and analyzed in robot, or vice versa. So that's, a lot of times rebar is not going to transfer between applications. It does in this case. So that's useful. I mean, it can be a lot of information. Yeah, oh. A good best practice for, I don't know, for tolerances between the analytical and physical model. I don't know if there's a rule. I mean, there's rules of thumb just based on the default values that are in there, right? 6 inches and a foot. When you start, I mean, the way I would look at it as an engineer is when I see the analysis starting to not behave the way I expect the structure to behave, right? Like when I start seeing that can't move in that direction, like then clearly my tolerances are too loose because it's starting to assume things about it, the way the model can move that I know aren't possible. So you have to use your judgment. But generally speaking, there's some flexibility there. Like people get really worried about whether the node is at the top or center of a member. It's not going to matter that much for most analysis, although you can be specific about that. What was the question? Yeah, so if you're doing anything with so the question is about how do you design connections in North America? So first of all, both Advanced Steel and Revit will check connections per code for any standardized connection that exists in either product. There's more of them in Advanced Steel than in Revit, but there's 100 and, how many is it now in Revit, David? 120 something types of connections that are available in Revit now, and it checks for code on those based on, shear pull out and all those, the standard rules of thumb for code. No, that's based on American codes or Eurocode. There's also, in Robot, there's more features for doing like intelligent connection design of non-standardized connections. But that's based on Eurocode. That's the part that you can't do here is just make up some crazy connection out of nothing and have it automatically checked by Robot. You'd have to do that with hand calculations or dedicated connection software. Yes? Yeah. That's from IDEA, or is another, yeah. So there are companies that make softwares that just do connections, but. Yeah. So there's a question in the back. So you. Yes, and you can do all kinds of seismic and, yeah. Yep. It doesn't do masonry. That gets a little bit funkier. Yeah. You talk about the wind load simulation I showed earlier? No, so that's a feature that's just inside Robot. You can export when you're done to CFD and do anything you want over in our CFD product because it is using that engine. But you define your area of interest based on what you've got in your model, the extent of your model. You define the pressure velocity and your directions of interest and the vertical wind factor, and that's it. And then you just let it run. You can tell it to stop converging when you want to, or let it run infinitely to close to convergence. But it's a live CFD, so it'll run for a while. But then the result, like I said, can be put into CFD if you want to do more constraints on it. But it's really just a whole building external wind load simulation. More questions? This side? Yes, sir. Absolutely. Yeah, so the question was, can we gear this up for other codes like Canadian building codes? Yeah, it's in the tools job preferences. You can set any of the 70 plus codes that come with the product. So yeah, you would of course configure it that way, and that would also generate your load combinations per code and everything else. Yeah. Yes, sir. Is there a plan to add masonry? I don't know. So yeah, right now it's a niche thing. I know, yeah. So there's always more. Yeah. If you didn't save that robot file and you just left, yeah, you'd have to regenerate that information. That exercise, by the way, if like when I fire that up, if you know the sequence, that's about a 3-minute. That whole exercise is maybe 3 minutes, right? You just click a couple of buttons, move through it, and go. There's just nothing to it, right? But yeah, normally you'd be saving your file, right? No, it should work. It should work well. It'll update the robot file. Yeah, I mean, it's good for that specific purpose of moving back and forth multiple times. That's where a lot of third-party tools are going to break down because it's not their fault, but they got to try to keep up with our releases, and the fidelity of going back and forth is not quite as strong. Yep. Sorry. Yes. What about React? I don't know that React will come out. So React Structures, which you can, if you're curious about, go to react.autodesk.com, was a series of test previews of a new UI, basically for Robot. It uses Robot Engine, but not only a new UI that fit into the Autodesk look and feel with the ribbon, but also a new UX. So simplified the steps to get to an analysis result. But it's an experiment. It went through 4 technical previews, and whether what was initially the purpose was before it was branded as React, initially it was going to be just updates to Robot to make it look like that. But there are so many users of Robot that have used it for 20 to 30 years in parts of the world that it was deemed inappropriate to rip it out from under them like we did with AutoCAD and change. Yeah, so it's one of those things where I don't know. Right now it's ended, that preview's ended. Although if you go to that website, then you'll see my data set from the Air Force Academy Cadet Chapel is featured on that page. Sorry, question up here?
You said that under the options you changed them to semi-different, correct?
Yes. Can you save those out? No, that's a good question. I don't know, actually, if I could save that as a template. Normally, you're not changing them that often. You're changing for that job. I don't know, though, if I could save that as a separate file. I think it's just more of a, when I first start the project, set it up, and then it remembers those settings from that point forward. But yeah, it's a good question. I need to follow up on that. It's basically a template that you... There you go. You got it from David in the back. He's saying, yes, you can set it up for, I work with this company, therefore I'm using that code, or I work with that municipality. There you go. That's something that's a good question. They'll stick. No, that information would stick. It's not something you would see or be able to edit in Revit, but when you go back to Robot, the information's still there.
So when you send it from Revit to Robot, it looks like it makes a new file, an unsaved new file. Is that the case, or is it kind of still that old file you've been working on, even if you close it? Yeah, so it depends on your workflow, right? If you are starting from scratch and you're not updating an existing model and you just say create a new one,